Hello everyone, I hope you all are having a great time. In this video, we are going to find out the indices for planes in hexagonal unit cell. Here we'll be given with some of the planes and they will be lying inside the HCP unit cell. And what we have to do is to first find out the indices for those planes. Okay. Now for HCP planes and directions, we need 4 indices in place of 3. Okay. Normally we used to find 3 indices for planes and directions in other unit cells, for example cubic unit cell. But here in HCP we need 4 indices to completely describe its direction and planes. So we call those 4-digit indices as the Miller-Bravais indices. Okay, while the normal 3-digit index system is known as Miller indices. Okay, so here we'll be finding out 4 indices for planes in HCP. Okay, and we find 4 indices similarly for directions in HCP. All right, now those indices are called as H, K, I, and L. Okay, H is the first index, K is the second, I is the third, and L is the fourth. Okay, the notations are arbitrary. You can choose your own. For example, in some books it's U for first index, V for second, T for third, and W for the fourth one. So it's totally up to you what notations you want to adopt. Once you have selected it, just stay fixed to that notation throughout the problems, then so that you may not get confused. Okay, so I'll take this one notation. Okay, H for first, K for second, I for third, and L for the fourth. Okay, now each index is correspondingly given by the coordinate axis. Now each of the index is obtained from the intercepts of a plane, okay, corresponding to a unique coordinate axis. For example, the H index is obtained from the intercept of A1 axis with plane, K index is obtained by the intercept of A2 axis with plane, while the I index is obtained by the intercept of A3 axis with plane, and the last index, which is the L index, is obtained by the intercept of Z axis with plane. Okay, so if we wish to find out 4 indices for the planes, then we'll have a 4D coordinate system. Okay, 4-dimensional coordinate system has to be established in HCP, and so we'll see now where these coordinate axes are located. Okay, and how the coordinate system look like. Before that video, I have also posted a video where I have explained in detail the whole prerequisite things that we should know before diving into the main problems. Okay, so I'll recommend you all to go and watch that video first and then come to this video, because that video, if you have already watched that video, then it will make the whole understanding process way easier. Okay, so I just recommend you people to go there and watch that video. I'll pin that video in the comment section. You can check it out from there, and I will also link it in the description box. So yes, now let me draw the coordinate system first, and after that we'll be doing the problems, because this whole video is concentrated on the solution of the problems. So this is one of the plane. Let us call it as a roof plane. Okay, and just below that one we'll make another similar shaped. So just below that one we'll make the similar structure here. This green line is a mistake, don't make it on your paper. Okay, all right, now we have to join each corresponding corner. Like for example, this corner and the reflection of this corner down here is this one, so we'll join this corner with this corner with this one with this. Okay, all corresponding corners will be joined to each other, and it will look like that. After that, and this with this, I just made this line away from this corner so that the line I make sidewise could be distinguished. Okay, so that we may know that this is one of the line and this is another. If we make it accurately, then they will, you know, overlap, and we don't want that structure, that shape of the structure. We want to distinguish all the lines. This with this corner. Okay, and here we go, and the centermost point in the this orange plane is called as the basal plane, as it is lying on the base region. Okay, we call it as a basal plane, and the centermost point here is called as the origin. Okay, this is the origin of our coordinate system. Now let me draw the coordinate axis lines, and the coordinate axis lines will look like that. Okay, take this corner, a vector from this to this corner is the A1 axis. Okay, this is the A1 axis direction. All right, this is the corner of the unit cell. Now leave that corner, move clockwise. Okay, we'll moving clockwise, leaving that corner untouched. The next corner to it will be taken as the second corner to make the second axis line, which is A2 axis, and here we go. This is the A2 axis, positive A2 axis. Now leaving the next corner untouched, the third corner will be the third axis lines corner. Okay, and this is the A3 axis. You can see here that the three of the axes, A1, A2 and A3 are lying on the basal plane. Okay, they are not on the height, they are lying flat on the base. This is A1 axis, this is A2 axis, and this is the A3 axis, and they all depend on each other, okay, by a relation which is h plus k plus I equals 0. Okay, they are dependent upon each other, but they are independent of z axis. Okay, that is why there is no L index here. Okay, only the three of the axis lines which are lying on the basal region are interconnected, but they are independent, or they are separated in another way you can say from the z axis. There is no fixed relationship between them and the z axis. So this is the relation that we can use whenever, for example, we know two of the indices, we can find out the third one. Okay, here h, k and I are the indices actually. So if you know h and k, you can find out I very easily using this relation. Okay, if you are confused, if you know I and h, you can find k. Okay, for example, the similarly if you take h and I on the other side of the equation, it will become like that, and so on. Okay, so this is one of the handy helpful relation that will help us to determine the indices, and this is another relation that I'll explain a little bit after describing the z-axis and the indices. Okay, so we'll come to that one point. If you already know all of that stuff, then you can directly jump into the part of the video where I'm solving the problems, because most of the students just come directly into this video and they have not watched the one that I have recommended. So that is why I'm just doing it again, a little bit introduction, and after that we'll be doing the problems, and I'll make the chapters. You can see the chapters and go to your desired problem directly from the chapters. And this is A1, A2 and A3 axis, and the line just vertically upward from center to upward. Okay, like that it is going upward. Okay, and here it goes out of the roof from the center point also. Okay, you have to visualize it in 3D. This is the z-axis. Okay, now now A1 will help us to give h index, the first index. A2 will help us to get the k index, second index. A3 will give us the third index I, and z will give us the L index. Okay, and they are once they are determined, we write them like that. Okay, enclosed in a round brackets, no comma in between them, no other sign. Okay, they are written like that. And if we, for example, have single values, then we, for example, 1 for h, 2 for k, I is 3, L is 4, single values, then we write them like that. Okay, enclosed in a bracket, 1 2 3 4, like that. But if we have, for example, 12 for h, okay, and for example k is 3, I is 24 and L is 4, okay, then we have to put a space between those numbers which are double. For example, 12, then a space 3, then space 24, then space 24, so that they could be distinguished to be like that. Okay, for example, if we will write them without spaces, then it will become difficult for us to know whether 1 is for h as index, or 12 or 123, and so on. Okay, so once they are more than one digit for a index, then you have to use the spaces in between them. Okay, so yes, now let's get back to this equation. Here A is the A1 intercept, B is the A2 intercept, and C is the Z intercept of the plane. Okay, and this equation is also used to find out the intercepts. Okay, and once we know the intercept, we can easily know the Miller-Bravais indices. And here A1, A2, and Z are the any point on the plane. Based on our requirement and what we, for example, want to find out from this equation, we'll find the appropriate point on the plane. We'll put that point right into this equation. Okay, all known quantities will be inserted in it, and what we have to do while taking out the appropriate point will be highlighted when we'll be doing the problems. Okay, so this equation is very important, and it makes the whole process very easy. Okay, the method I'm going to illustrate here is very easy, and yes, let's get into the problems. And if you are confused about the concept of intercept, that what it is and how to find it and how to determine it by just looking at the figure, so don't worry, we'll see it, and we'll have a deeper look of intercept later on in the video. Finding out the intercept is a core step in finding out the indices for the planes. Once you have found the intercept, then there is nothing left behind anything difficult. There is only one or more step that needs to be done on the intercept, and you will get the indices as a result. So finding out the intercept is the tricky thing here. And yes, here the selection of the coordinate axis. Okay, here the selection of the coordinate axis name is arbitrary. You can choose this one as A1 axis, this one as A2, this one as A3, and this selection is arbitrary. Okay, in some books this is taken as A2, this one taken as A1, this is taken as A3. In other books even this happens that they take this as positive A1 direction, and this is as A2 and this as A3. Okay, this selection is totally arbitrary, and you don't have to worry about what you have selected before and what the book has selected. Okay, you have to carry on the coordinate system that is given to you. Whenever the blend comes to you, there is a predefined coordinate system in it, and if that coordinate system's origin is not passing through the plane, then you do not have to change it. You will proceed with your problem by simply following that coordinate system. Okay, so the problems that I'm going to do in those problems, this one direction is taken as A2 direction, this one as A1, and this one as A3. There is no problem at all. We'll follow it. Okay, so yes, here's the plane whose Miller-Bravais indices are indices we are going to find out, and there will be other planes too. Okay, and we'll do them one by one. Here's the first one. I'll draw this plane right into the paper. We have already drawn a HCP unit cell, so that I can refer to you people and make you people understand how the intercepts are gonna be determined. Okay, so let me draw it on the paper. You can see it clearly where the plane is lying. For initial thought, you can see here that the plane is intersecting the A3 axis right into this point. Okay, this is the plane. Here's the plane, and you can see the axis lines to be this, this, and this. Okay, these are the basal lines. We'll talk about the z-axis later. Okay, I refer to this figure also on the paper. Okay, but for the initial thoughts, I'm just to make you people understand the diagram itself, that the plane is intersecting the A3 axis right at this point. Okay, right at this point. So it is intersecting A3 right at the corner of the unit cell. So now you can people see that the plane is intersecting A3 right at the corner of the unit cell. If the plane is intersecting at the corner of the unit cell, then that numerical value will be taken as 1. Okay, so the intercept will be taken as 1. All right, if it is intersecting right at the middle, for example here, then we will take the intercept to be 1 by 2. Okay, if it is intersecting at 1/3 point, then we will take it as 1/3, and so on. Okay, depending upon which fraction of the full length the plane is intersecting, we take its numerical value depending upon that. Okay, if it is intersecting right at the corner, okay, then we'll take it as 1. If it is intersecting at the middle of the full length, okay, then we'll take it as 1 by 2, and so on. I'll make it clear also on the paper for you people. and now we know that the intercept of A3 is 1. Now if you talk about the A2 intercept, then here is the A2 axis, okay, is going like that, and if you notice, then the corner just opposite to A2 corner is this one corner, okay. So it is negative A2 axis, it corresponds to a negative A2 axis. This is the positive A2 axis, and that would be the negative A2 axis, and the plane is intersecting the A2 axis at the negative direction and also at the corner of the unit cell. So the intercept corresponding to A2 will be taken as -1. All right, and if you consider the A1 axis, which is in this direction, and also you can see the plane's base, which is this baseline, is also in this direction, which is parallel to A1 axis. So the plane is actually parallel to A1 axis, because the base of the plane is actually the plane's part, okay. So if it is parallel to A1 axis, then the plane as a whole will be parallel to A1 axis, and two parallel lines never intersect each other, they intersect at infinity mathematically. So the A1 intercept would be taken as infinity, and the similar is true for z-axis. As you can see here, these vertical lines, okay, here that the plane's vertical line, these are the plane's vertical line, okay, and they are parallel to the z-axis, as the z-axis is vertically upward, and the plane also has the boundary lines, okay. You don't need to see all of the lines, you can see the boundary lines, and the boundary lines are these ones, okay, and they are parallel to the z-axis. So corresponding to z-axis, the intercept is infinity also, because the plane is parallel to the z-axis, and hence they will never intersect, and mathematically we can write this as the intercept to be infinity. So A1 and Z intercepts are infinity, while A3 and A2 intercepts were discussed to be 1 and -1 respectively. Now let us see this image also on the paper. I hope you got it. So if I shade that one plane which we discussed right now, this is the plane, okay, and clearly it is intersecting, this is the A3 axis, okay, and here is the plane, and this is intersecting the A3 axis. It is touching the A3 axis at this point clearly, which is the end of the, which is the corner of the unit cell, and we take the whole length from origin to the corner of the unit cell, okay, along the axis direction. The length will be taken as 1, okay, along the axis direction, not any other. It will be taken as 1, all right, and if it is touching at half of the point, okay, half the distance from the corner of the unit cell, then it will be taken as half, and so on, okay, depending upon the fractional distance from the corner of the unit cell, and hence the intercept corresponding to A3 axis will be 1, and here is the positive A2 axis, and here is a negative A2 axis, and the plane is intersecting this axis, A2 axis, at this point in the negative direction, so its intercept will be taken as -1, since it lies at the corner of the unit cell. And we can also see the boundary lines here. This is the boundary line, and it is parallel to A1 axis, okay, it is clearly parallel to A1 axis, that is why its intercept will be taken as infinity. And similarly for z axis, the intercept will be taken as infinity, because the boundary line of the plane are parallel to z axis, okay. Hence we have A1 intercept, okay, A2 intercept, A3 intercept, and Z intercept to be A1 intercept is infinity, okay, A2 intercept is -1, A3 intercept is 1, and Z intercept is infinity again. Now we'll take the reciprocal, okay. The second step is to take the reciprocal, and taking the reciprocal of infinity, 1 over infinity, which comes out to be 0, okay, 1 over infinity is equals to 0. We'll take inverse of -1, and it is -1 again, Inverse of 1 is again 1. Inverse of infinity is 0. So we got 0, -1, 1 and 0 as the final indices, because we can see here there is no fraction involved. That is why these are the final bravais indices or indices of plane for this specific plane. Hence we'll enclose these digits in a round bracket. The first index was 0, second as 1, third as -1, that we represent as 1 with a bar on it. Okay, 1 with a bar on it, or any numerical digit with a bar on it, means it's a negative number. Okay, so -1 and 0 again. So these are the Miller indices, Miller bravais indices for the plane, for this plane. Okay, now let's do the next problem. This problem was pretty easy, because all of the intercepts were easily determined by just looking at the figure, but there are some problems, other problems, where we cannot have an idea of intercept by just looking at the figure. We have to use the mathematical tools, and the mathematical tool that I'm gonna show you is very easy, and you can determine the Miller indices very easily via those mathematical tools. So here's the next plane, and we can see here the plane in the orange shade. Okay, and if we see here, if we keenly see the boundary lines of the plane, then here are the boundary lines of the plane, and the coordinate axis are also predefined here. Okay, and we can see here. All right, now these are the axis line, and the plane, the green line you can see here, is intersecting the 3 axis at some point. Okay, at the basal region, and for the z intercept we'll do it later, but first of all let us see where the plane is intersecting the a1, a2 and a3 axis. For that, let me remove these colors. Okay, now you can see here for the case of a1 axis, okay, that it is a 3D diagram. Don't confuse that this plane is intersecting a1 axis at this point. No, it is not intersecting here. The plane is not there. If you imagine its position, then it will be very clear to you that the a1 axis is just beyond this plane. Okay, this plane is away from a1, positive a1 axis. It is not intersecting it at positive a1 axis, but this is one of the corner a1 axis, and the corner just opposite to that a1 axis is this one corner. Okay, this this one corner, and it is negative a1 axis, and the plane is intersecting it right there. Okay, at a negative a1 axis. So the intercept for a1 will be corresponding to the a1 axis will be -1. Okay, for the reason that here is the corner, and the corner just opposite to it will correspond to the negative a1 axis, and the plane is clearly cutting it at the edge of the unit cell along the negative a1 direction. That is why the intercept along a1 direction will be taken as -1. Okay, now let's talk about a2. Here is the corner for a2, and the corner just opposite to the positive a2 direction is this one. Okay, and the plane is clearly touching it at this point. All right, so similarly this was the positive a2 direction, hence this is the negative a2 direction, and hence the intercept for a2 axis will be taken as -1 also. Okay, you can see here that the plane is cutting a2 axis at the negative direction and at the corner of the unit cell. That is why its intercept will be taken as -1. All right, now if we talk about the intercept corresponding to a3 axis, we can have an idea, a rough idea. We can see here that it is cutting, here is the plane. Okay, and this is the axis line, and we can see here it is cutting, the plane is cutting the a3 axis somewhere at the middle. Okay, somewhere at the middle of this whole length. This whole length is 1, and half of it is 1/2, so it is cutting at half by at half. Okay, the plane is cutting a3 axis as half in positive direction. We can also confirm it whether it is half or not, because we have that equation h plus k plus I equals 1. Okay, h plus k plus I equals 1, and remember that this equation holds for the Miller indices, not for intercepts. So first of all, if you want to know the value of I, which is the intercept corresponding to a3 axis, okay, so what you have to do is to first find out h and k, taking the inverse of a1 and a2 intercept. Okay, will give you the h and k values, so you can find out the value of I from that one. Also we can confirm it from these two equations whether the intercept corresponding to a3 will be 1 by 2 or not. Okay, we can confirm it. We can even don't need to find out intercept that way. We will finally find out the value of index corresponding to a3, that will be I. And for z, I'll give you some other method that will help us to determine the z intercept very easily. So we have successfully found the intercept, a1 intercept to be -1, a2 intercept to be -1 again. Okay, and the a3 intercept is half, but if you want to confirm it, you can do that. For this, you need to find out the value of h, and h will be equals to the inverse of -1, because we take inverse of intercept. Okay, in that case, inverse of -1 is again -1, and there is no fraction involved, that is why -1 is the final index. And similarly, because there is no fraction involved when we take the inverse of both of these quantities, that is why taking the inverse will give us the final Miller indices for h and k. Now we want to find out the value of I, and for that purpose we'll use this equation, okay, where I will be equals to -h minus k, and I equals to minus, taking minus common, h plus k. Okay, minus into h is -1, k is -1 again, so minus into -2, that will give us 2. So the index is I is equals to 2. So if you want to find out the corresponding intercept, we take the inverse of index, that will give us intercept. Okay, if you take the inverse of this a3 intercept, which is 1 over 2, you will get I, and for this you will do that, and it will result into 2. So it's confirmed that I, which is the third index, comes out to be 2. So we now know 3 of the index, -1, -1 and 2, but the fourth index needs to be determined, and for this we'll use the equation of intercept. We know that equation of plane, okay, a1 by a plus a2 by b plus z by c equals 1. Okay, where a and b are the intercepts corresponding to a1 and a2 axis. Okay, and c is the intercept for the z axis. Okay, which is something that we need to find out. C is something that we need to find out because c is the z intercept. Okay, a and b are known. Okay, a and b are -1 and -1, and a1, a2 and z are any point on the plane, any suitable point on the plane. Okay, an appropriate point has to be taken so that we can find the value of c. And in taking the point on the plane, do remember that whichever intercept you want to find out, for example here we want to find out the z intercept, so the z point, now the z coordinate shouldn't be 0, okay, of the point on the plane that you are selecting to put into this equation, because if the z is 0, then this whole quantity will become 0 and c will be eradicated from the equation, and but c was something that we wanted to find out. Okay, so I hope you got the point that the appropriate point is the one whose that coordinate is not 0, whose intercept we want to find out. All right, and depending upon the unknowns also, you'll see its application in later problems. Okay, so let me take one point on the plane, and I will get you people onto that page where the plane was. Now let us take a point on this plane. Okay, and that point should have the z coordinate to be non-zero. Okay, we should keep that thing in our mind. So now let's see what we can do here. The most suitable point to me looks like this one. Okay, this is the most suitable point, or this one, that one, but the first one is better. Now we need to find out the coordinates of this point. Okay, starting from origin, what we have to do, what a movement are needed along the axis lines to reach that point. those moments will define the coordinates. So starting from origin, here we have to move 1 unit along the positive a1 axis, okay, at that corner. The line was not straight, but along the axis line of a1 to that corner of the unit cell, so that we have to move 1 unit along a1 direction, okay, positive a1 direction, and from that point onwards we have to move 1 unit along the z-axis. 1 unit means to the other corner of the unit cell along the z direction, which is this point. Okay, so we reached that point now, and that point is what we needed, and that point is the one that we are going to put into the equation of plane equation. Okay, so here we have to move 1 unit along the z direction, and no motion along a2 axis is needed to reach that point. So no motion is needed across the a2 axis. Okay, a3 axis is neglected here, keep that in mind. We are considering only a1, a2 and z axis here, and also in accordance to the equations requirement, a3 axis is not considered. So no motion is required along the a2 direction, and hence for a1 the coordinate is 1, for a2 the coordinate is 0, and for z the coordinate is 1. And the a1 a2 intercepts are known also. Okay, we'll just plug their values into that equation. Keep that in mind, these are the intercepts, note the Miller indices that we are going to plug in into the equation of plane. Okay, keep that in your mind, that intercept and indices are two different quantities. Okay, they are not necessarily equal to each other. That is why that differentiation should be in your mind. Okay, so let's put these values into the equation. Okay, so let me put these values here. In place of a1 I'll put 1. Okay, in place of a we'll put the a1 intercept that we got as -1. Similarly for a2 we'll put 0, and for b we have -1 here. So but it's not necessary to put the value of b here, because this 0 our on numerator will make this whole quantity to be equal to 0. Z is 1 and c needs to be determined. This will become -1 plus 0 plus 1 over c equals 1. -1 gets to the other side of the equation, and we have 1 plus 1, which is 2. 1 over c is equals to 2, which means if we take c here and 2 here, 1 over 2 equals c. Okay, so the z intercept came out to be half. Okay, this is the z intercept, and we take the inverse of intercept. So inverse of intercept is this. Okay, now we can see here that this is not a fractional number, that is why this is the final index. Okay, L equals to 2. All right, we take the inverse of intercepts, and after taking the inverse, if there is no fraction involved, okay, then the number we obtained will be the final index corresponding to that axis. Okay, so L is equals to 2 here, and we got A to be -1, K to be -1, I to be 2, and Z L as 2. So H, K, I, L are 1 bar, 1 bar, 2 and 2. All right, so these are the Miller-Bravais indices for the plane that we discussed. Now here is the next plane whose indices we are going to find out. Okay, in orange color, this is the plane, and first thing that we do in finding out the indices of the plane is to define the coordinate system. Obviously, as we can see here, the coordinate system is already defined. Now the next step is to find out the intercepts. Okay, now for the intercepts, the first thing that we should do is to find out those intercepts that we can find determine by just looking at the figure. Okay, there are some other ones which couldn't be determined by just looking at the figure. We have to do some mathematical stuff, but here the first thing is I'm looking at the boundary lines of the plane, and so if you notice, then if we look at the boundary lines of the plane here, okay, the first inspection, we can see here that this is the straight boundary line of the plane, and we can see here that this boundary line is parallel to the z-axis, which is also vertically upward. Okay, like that you can see here. So if one of the boundary line of the plane is parallel to the z or any axis. For example, if one of the boundary line is parallel to any given axis, then one of that axis intercept will be taken as infinity. You can see here that the plane is parallel to the z-axis, so the z-intercept here is infinity. Okay, so we have successfully found the z-intercept, which is infinity. Now if we look at the other um, directions, okay, for the other intercepts, you can see here that here this is the a1 positive a1 axis, and from center to the corner of the unit cell is taken as 1. This length is taken as 1, and we can see here that the plane is cutting that a1 axis right at this point. Okay, right at this center point. So we can see here that the a1 intercept is 1 by 2 again. Okay, now if we talk about a2 axis, you can see here this is in this direction, a2 axis, and the corner just opposite to this corner of the unit cell is this one corner. Okay, um, you can see here that here is the corner for the positive a2 direction. Okay, and the corner just opposite to that is this one, and this is for negative a2 direction. So if we draw an axis line starting from origin to this direction, this is a negative a2 direction, and the plane is touching the axis line, a2 axis line, in negative direction by unit -1, because it is at the corner of the unit cell, and numerical value for the corner of the unit cell is taken as 1. Okay, and if it is negative directions, then -1. So a2 intercept comes out to be -1. Okay, so for a2 axis the intercept is -1, for z axis the intercept is infinity. Okay, and also for a3, okay, this is the corner for positive a3 direction, and the corner just opposite to that, this corner is this one corner. Okay, and this is negative a3 direction, and we can see here that the plane touches the a3 axis in negative direction here, okay, at the corner. So the intercept for a3 direction will be taken as -1 here. Okay, so we can see here that we got -1 intercept for a2, -1 intercept for a3, infinity as intercept for z direction, and 1 by 2 for a1 direction. And we'll now some of these students gets confused whether it is 1 by 2, 1 by 3, or something like that. And if there comes a case where you are totally confused and you cannot make an idea, and it is quite clear here that it is cutting at the center point. But even in a case when you don't know, okay, you don't know whether it is 1 by 2, 1 by 3, 1 by 6, 1 by 8, you can use that equation. Determine it by using that equation, h plus k plus I equals 0. Okay, we can will determine the indices for a2 and a3, which will give us I and k. Okay, and if you know I and k, we can easily determine h. Okay, so if you're confused, you can use that one shortcut also, but you can also use the equation of planes that I mentioned that we used earlier. Okay, but I'll use this one because that one is not needed here. So for a2 the intercept was -1, a3 intercept was -1, and z intercept was infinity. Now we'll take reciprocals. Okay, in case of planes, we take reciprocals by in directions. Okay, in determining the indices of planes for directions, we do not take inverses there. Taking reciprocal is one of the important step in determining the indices in case of planes only. So we'll take inverse of -1 is -1, inverse of -1 is again -1, inverse of infinity. Taking inverse means situation like that, 1 over the quantity, and 1 over infinity is 0. Okay, so we can see here there are no fractions involved, so these are the final indices. A2 intercept will give us k index, a3 gives I index, and z gives L index. Okay, so k is equals to -1, I equals -1, L equals 0. Now we want to find out h when we know k and I, okay, already. So h will be equals to -k minus I. If we take minus as common quantity, then this is like that, putting values here, and we get this minus into -2, and this gives h equals 2. So the h index is 2 here, And if we join all of these values together, h first, which is 2, k then, which will be written like that, a bar on it which shows negative number, okay, and 1 bar 0. These are the final Miller indices, Miller-Bravais indices for the plane that we were given, okay. And since we can see here that h index come out to be 2, and if we talk about its intercept, because we take reciprocal here of intercept, and that then we get index, so the index is 2, so if you take reciprocal of index, you will get the intercept, which comes out to be 1 by 2. So the intercept was 1 by 2 as we guessed, okay, and we guessed it right. So yes, okay, let's do the next problem. And here's the next plane, okay, whose indices we are going to find out. And first of all, we'll look at the plane, okay, whether there are some of the intercepts that we can find out by just looking at the figure. So yes, this is the positive a2 direction, and you can see here clearly that the plane is touching that a2 axis at this point, okay, at the corner of the unit cell. That is why the a2 intercept will be taken as 1, okay. This is the a2 direction, all right, and the plane is touching it right at this point. You can see here the dot I mentioned here. So the a2 intercept comes out to be 1, okay. One of the thing is done now. And if you talk about the positive a1 direction, this is the positive a1 direction, okay. This is the corner. Here's the corner for the positive a1 direction, and the corner just opposite to that one corner is this one corner, and this one corner will be taken as the negative a1 direction. We can see here that the plane is cutting or touching the a1 axis in the negative direction at the corner of the unit cell. That is why the a1 intercept will be taken as -1. All right, two of the intercepts are already determined, and yes, two of the corners, two of the intercepts are known now, and these two will give us a1, and a2 intercept will give us h and k, and we can easily find out I by using that equation, h plus k plus I equal to 0. So we do not need to worry about the a3 intercept, like we don't need to make any guesses. I think the index will come out to be 0, but we'll see it, okay. We can confirm it by using this equation at the end. So the a2 and a1 intercept are confirmed now. And if we talk about the z intercept, which couldn't be determined by using that one equation that I mentioned here, we have to use that one equation of plane in order to find out the z-intercept, because by just looking at the figure we cannot make an idea of where the z-axis would be cutting the plane, or the plane is touching the z-axis. So we have to use that mathematical tool, and because in that equation, a1 by a, a2 by b plus z by c equals 1. We already know a and b here, okay. A is the a1 intercept, okay, and b is the a2 intercept. We already know that, okay. A1, a2 and z are any point on the plane, and c is something that we need to determine. C is the z intercept. So let us take one of the point on the plane, okay, and we have to take only a1, a2 and z point. We have to consider the 3D instead of 4D. We have to ignore a3 direction completely. So, and in addition to this, we have to take that z point in addition to this, we have to take an appropriate point, because we want to find out the z-intercept. So the point should be such that the z coordinate shouldn't be 0 here, okay. Any other coordinate could be 0, but the z coordinate shouldn't be 0, because we need to find out the z-intercept. And if the z coordinate is 0, then the c will be eradicated from the equation, and we don't want that. We want to find it actually. So taking this point, okay, on the plane, because this is the easy one. Now starting from origin, this is the origin. What we have to do to reach that point will give us the coordinates for the point. First, what we have to do is to move 1 unit along a1 direction to the corner of the unit cell, okay. 1 unit along a1 direction, so a1 coordinate is 1. And after that we have to move upward, okay, to the other corner of the unit cell, which is this, okay, which is this. Starting from this point to this means 1 unit along the z direction, and we reach that point, which is also a point on the plane. So we do not have to move along the a2 direction. Okay, also we do not need to move along the a3 direction. So we do not need to move along a2 direction, so 0 coordinates for a2, and for z we had to move 1 unit in positive z direction and also positive a1 direction. So these are the coordinates that we need to put in to these, okay, in place of these ones. And the value of a and b is also known, so we have to find out c simply. So let us plug these values into this equation and get the c intercept, and after that we'll determine the indices whose intercepts are known. And after determining the indices for a2 and a1, we'll determine the indices for the a3 axis, which will give us I at the end. So let us do this. So these were the points, and this is the a1 intercept and this is the a2 intercept. So here we had the equation. All right, now putting the values here, a1, a2 and z are the points, are the coordinates of the point that we selected, and these are the coordinates. Okay, 1, 0 and 1. So putting 1 in place of a1, here a is the a1 intercept that come out to be -1, so here. Then a2, which is 0, by b was 1. Okay, b is the a2 intercept. That doesn't matter because a2 point is 0, so it will make the whole quantity 0 already. And z is 1. Okay, 1 over c is the z intercept that we need to find out, and -1 here, plus 0 plus 1 over c equal to 1, and taking -1 onto the other side of the equation and we get 1 plus 1, 1 over c equals 2, and taking c here and 2 here, it becomes 1 over 2 equals c. Here c is the z intercept, which came out to be 1 by 2. All right, so a1 intercept was -1, a2 intercept was +1, and z intercept, which we called as 1 over c, is 1 over 2. Okay, next step is taking reciprocals. Taking reciprocal of -1 is 1, -1. Okay, reciprocal of 1 is again 1, reciprocal of 1 over 2 is 2. Okay, inverses, we are taking simply the inverses. This is, since there is no fraction involved, nothing else needs to be done, and these are the final indices. If there would have been any fraction involved, then we have to remove the fraction by multiplying all of the numbers with a suitable digit such that the fraction gets removed. And this is for a1 intercept will give you h, a2 intercept will give you k, z intercept will give you l. Okay, so this is the value for h, this is for k, and this is for l, and we need to determine the I. Okay, we have to determine 4 indices, you know. So we had this equation. Basically putting these values here h is -1 plus k is +1. Okay, -1 plus 1 gives you 0. As I told earlier, I intercept is 0, which means a3 was parallel to the plane and I is 0. Okay, so HKIL come out to be 1 bar for H, K is 1, I is 0, and L is 2. So these are the indices of plane for the plane that we just saw. Hence, in this way, these four problems are done. Now we will do other problems also, but in a separate video.